My name is Corbin Greer, and I'm recording my explanation for my graph algorithms program for the class CST 201. Starting off, I'm just going to run the algorithm to show you what it produces. So I'm writing this algorithm to try to produce all the cycles that are in this graph, as well as showcase which one is the smallest in terms of weight. So if we look at our code here, I scrolled through a little fast there, but you can see there is a lot of cycles in this graph that it can find using this algorithm. But at the end of the day, we have one that has a -1 weight, and that is the smallest one in this graph. Now, to accomplish this, I use two classes. One class was a cycles class. So in this class, I just had the weight of the class recorded and the path that it used. That way I could print it out. And in this class has all the basic getters and setters and constructors as a constructor that we use to put into the path. A get weight, add weight, remove weight, get path, set path. And I also have a print cycle method to make the main method a lot cleaner. But there's not too much logic to explain there. That's pretty basic code. Now down to the real logic in this program. So I have an algorithm method that creates an array list of cycles that we just created the class for. And then for every row, loops through every row, we create a 2D matrix of what paths we have visited, what nodes in the exact edges that we visited to make sure we get every single one. And then we create just a new array list of integers for the current path that we're tracking to add a cycle. And then we call our recursive method that I'll show you later. And then we also have a cleanup method after we get all the cycles to clean up cycles that aren't actually cycles, but just got return cycles if our recursive method added them to. And then we just return all the cycles that we get, the main one. Now, in our recursive method, we put in the matrix, two 2D arrays, one for the graph, one for what we visited, two integers, one for the starting row or node that we have, and what row we're on. Then we have an array list of integers for what path we're currently working on, another int for the current weight that we're working on, then obviously the whole list of cycles. First, we have a base case that if we're at start or greater than 1, we create that cycle, we add the weight to that cycle, we add that cycle to our array list of cycles, and we just return the method. And then we loop through all of the options or in the column of what row we're currently on. If we have a possible next move, we just continue. And we use that with this if else statement. And then once we continue, we make sure we have visited that available path. We add the next move to the path. Then we recursively go on to the next move. And we don't use the return here. So that way we can backtrack right after by removing the last move we just made and making sure we haven't visited it. And that way we can check every single possible cycle and return every single possible cycle in that array list. And then after we have found all the possible cycles, we have one more method that just loops through our array list of cycles using an int variable, and a cycle variable, and finds the smallest one by looping through and testing if the smallest one has a smaller weight than what whatever weight we're currently at for smallest weight, returns that cycle so that we can print that out after we print out all the other cycles that we found. So that is my explanation for the graph algorithms program. Hope you enjoyed it, and thanks for watching.